Watch closely when this rubber ball hits the ground. It flattens out, stops for a split second, and rockets right back into the air. But if you drop a solid glass ball on that exact same floor, it doesn't bounce at all. It either thuds or shatters. Ava, Hannah, and Kitty are dodging a dozen rubber balls flying around the lab. Seeing them ricochet everywhere raises a question. What exactly determines whether an object flies back up or stays down? To understand that motion, we have to freeze time and look at the precise millisecond a ball smacks into the floor. Because they bounce so high, it's common to think bouncy balls have a spring hidden inside. But if you cut one open, it's solid rubber all the way through, meaning the bounce is a result of how the material itself reacts to impact. First stage, the squish. Hitting the floor, the bottom edge presses flat, storing the energy of the fall inside the rubber. Second stage, the spring. The rubber immediately snaps back to its round shape, releasing stored energy and launching the ball upward. This ability to squish under pressure and instantly return to an original shape is called elasticity. If an object cannot physically deform and snap back, it cannot store and release energy in this way. To measure how elastic materials are, physicists use a scoring system called the coefficient of restitution. The score is determined by comparing the original drop height to the height it reaches after the bounce. The closer those two numbers are, the more elastic the material is. A super ball made from synthetic Sectron rubber has an incredibly high score, returning to 90% of the height it was dropped from. Because the rubber returns almost all the energy it absorbed during the fall, it can continue bouncing much longer than other materials. To see how that elasticity compares to other materials, let's look back at that glass ball. In a side-by-side comparison, both objects hit the ground at the same speed. The rubber ball squishes and rebounds. The glass marble simply breaks. Glass is too rigid to deform. Since it cannot squish to store energy from the fall, the force of the impact has nowhere to go but into the structure of the glass itself, causing it to crack. We see the same lack of elasticity in objects like bowling balls. A bowling ball is too massive to change shape on impact. Instead of springing back, the energy is lost as a heavy thud. This shows the consistent relationship between shape and motion. Without a squish, there is no spring, and without a spring, there is no bounce. Let's see what you've learned. Question 1. What must a bouncy ball do the moment it hits the ground to store its energy? It has to squish. Question 2. Based on what we saw with the marble, is a solid glass ball capable of bouncing? No, it's too rigid. You've got the basics down. To join the lab crew for our next experiment, make sure to hit the subscribe button. To recap, bouncy balls work because they squish and spring back, a property known as elasticity. Harder objects like glass or metal don't bounce effectively because they are too rigid to store energy by changing shape. You can test this yourself. Ask a grown-up to help you drop a rubber ball and a heavy metal coin at the same time. You'll see exactly how elasticity changes the way they hit the floor. Now that you know why balls bounce, what happens when the entire ocean is full of something you can taste? Tap right here to find out why the ocean is salty.